Let's work a couple more problems putting expressions into the harmonic form. In this problem, we're going to add the additional restriction that our phase shift be between negative pi and pi. Right? But more on that in a little bit. Let's go ahead and start by employing the method that we used in the previous video. Right? Going to draw the coordinate plane, and we're going to put a triangle in an appropriate quadrant. The coefficient on the cosine is negative 5. Coefficient on the sine is a positive 12. So here I have the point negative 5, 12. And that leads me to look at this right triangle in quadrant 2. Using the Pythagorean theorem, the hypotenuse is 13. And recall that that is going to be the amplitude in our harmonic form. For the phase shift, for the alpha, we need to satisfy two conditions. The cosine of alpha has to be negative 5 over 13, and the sine of alpha has to equal positive 12 over 13, right? So alpha has to be a rotation that lands us in quadrant 2. Okay. There's alpha. Moreover, alpha has to fall between negative pi and pi. Well, certainly an angle between 0 and pi is sufficient to do the job. And thinking about 0 to pi, cosine inverse is a function that kicks out rotations between 0 and pi. So for my alpha, I can choose cosine inverse of negative 5 over 13. Right? When I do so, this is an angle whose cosine is negative 5 over 13, certainly. Moreover, since it's going to land in quadrant 2, right, and given this ratio, I'm going to get a positive 12 over 13 for the sine of that angle. Right? So this is going to be our phase shift. The harmonic form then is 13 cosine of x minus cosine inverse of negative 5 over 13. Let's work one more, adjusting the problem slightly. Instead of a positive 12 sine x, what if we have negative 12 sine x? Well, this time, right, in the coordinate plane, coefficient on cosine is negative 5. Coefficient on the sine is negative 12. So now I'm working with a point in the third quadrant. So here's my reference right triangle. Pythagorean theorem, the hypotenuse is going to have like 13. That's going to be our r. So what about the phase shift? Well, I can't use an angle that goes all the way around in the positive direction because I'm bound between negative pi and pi. So my phase shift is going to be that angle there, right? And it has to satisfy two conditions. Cosine of alpha has to be negative 5 over 13. Sine of alpha has to be negative 12 over 13. So what if I try and do what I did in the previous video? What if I try to use cosine inverse of negative 5 over 13? Well, like we just said, cosine inverse spits out values between 0 and pi. So what this is actually going to do, let's call it beta. Beta is going to give us a positive rotation that gives us the mirror image of what's going on down in quadrant 3. Right? This point up here would be negative 5, positive 13. Right? So this is not the angle that I want, but if I just want to take this picture and fold it down in order to get my alpha, then instead of this angle, I simply want the negative of that angle. So my alpha is negative cosine inverse of negative 5/13. So the harmonic form, 13 cosine x minus negative cosine inverse of negative 5/13. And we can simplify that a little bit, right? Subtracting a negative, we can change that to a positive. So here's the harmonic form for this expression. And notice, since we used cosine inverse here, again, cosine inverse spits out an angle between 0 and pi. The negative is going to give us an angle between negative pi and 0, so this alpha indeed satisfies the restriction.